Hi guys, welcome to Science in 5. In this video we're going to talk about applying Newton's second law, part 1. To be able to apply Newton's second law, we're going to first calculate the net force that acts on the object. And then once we get the net force, we're going to say the acceleration is equal to the net force divided by the mass. This is the approach we're going to adopt in this video. We're going to practice how to calculate the net force on a variety of diagrams, and then we can get the acceleration by just saying net force over mass. Okay, we've got two activities here. We are asked to draw a free body diagram for each block and to calculate the acceleration of each block. We're going to apply Newton's second law, Fnet equals ma. Let's go. For number one, I can see that there are horizontal forces that are acting on this object. So I'm going to represent the 25 kg with a dot like that. Then there is a 50 Newton force that is going to the east, and there's a 35 Newton force that is going west. Notice the relative length of the arrows. The 50 Newton has to be longer than the 35 Newton. Okay. And then the vertical forces that are acting, I'll have the normal force and I'll have the weight. Okay. Now, since this object is moving horizontally, it means the vertical forces will not have an effect on the motion of the object. Why? Because the vertical forces will have a zero component in the horizontal direction. Okay, so which means I will need to only consider the horizontal forces. Okay, so now let's apply Newton's second law. Newton's second law says Fnet equals ma. What is the net force going to be? Well, I'll have to make one of the directions positive, one of the directions negative. In this case, I've chosen the east as positive, the west as negative. So 50 plus a negative 35 should be equal to 25a. 50 minus 35 becomes 15, which is equal to 25 of a. Then solving, I get a equals 15 over 25. Both of these numbers are divisible by 5, so this becomes 3 over 5 meters per square second. In which direction? East. Okay, now let's look at diagram number 2. Diagram number 2, I've got the applied force at an angle. So what am I going to do in this case? Draw the component of that force. So there is the horizontal component of that force, Fx. The vertical component of that force will be going downwards. I'll call it Fy. Then I can feed in the normal force. Then I can have my weight, and in this case the friction is going in that direction. Again, it's always useful to draw the component diagrams because they are useful for calculation. Again, the same idea. I'm going to look at the horizontal forces only, and I'm going to make this direction a positive, this direction a negative. Now I can apply Newton's second law. Okay, so Fnet is equal to MA. So Fx plus Fk is equal to 50 of A. So what is Fx? It's the horizontal component of the 75 Newton force. So this is the same as 75 cos 30 plus a negative 25 is equal to 50 of A. The left hand side simplifies to 39,95 is equal to 50 of A. Divide both sides by 50. You get A equals 0,80 meters per second west. So at this time, it's practice time. You've got two questions. Question 1, there's a 25 Newton force pulling the block west. There's a 12 Newton frictional force going east. Diagram 2, there's a 50 Newton force acting at 30 degrees to the horizontal, and then there's 17,5 newtons going west. Draw a free body diagram for each block. Calculate the acceleration.